The engine control module, or ECU, is the brain of your car. It constantly monitors sensors throughout the engine, such as oxygen, temperature, throttle position, and crankshaft sensors. Based on this data, it adjusts critical systems like fuel injectors, ignition timing, and emission controls in real time to optimize fuel efficiency, reduce emissions, and maintain engine power. Think of it as the central command unit that keeps your engine running smoothly and efficiently. Watch out for these signs of a failing ECU. A persistent check engine light indicates the ECU has detected an error. Engine stalling or rough idling occurs when the ECU fails to properly control fuel injection or ignition timing. Reduced acceleration and poor fuel economy result from the ECU not optimizing air-fuel mixtures. Difficulty starting the engine happens when the ECU can't properly sequence the ignition system. Activation of ABS or traction control lights occurs when the ECU affects vehicle stability systems. Erratic shifting in automatic transmissions indicates the ECU isn't properly controlling the transmission module. Any of these symptoms could indicate ECU trouble and should prompt professional diagnosis. A flashing or constantly lit check engine light is a primary indicator that the ECU may have detected an issue. The ECU constantly monitors engine sensors and systems, triggering this warning when problems are found. To diagnose further, use an OBD2 scanner to connect to the vehicle's diagnostic port and read trouble codes stored by the ECU. Common error codes include P0300, which indicates random or multiple misfires detected by the ECU. Note the specific code and research its meaning online or in a service manual. This is the essential first step in diagnosing ECU-related problems. ECUs can fail due to several common causes. Electrical faults like corrosion or damaged wiring can disrupt power supply to the ECU. Overheating from extreme temperatures can cause ECU components to fail. Software glitches from bugs in firmware are common causes, particularly in older vehicles without updates. Physical damage from vibration or water ingress can crack components or cause corrosion. Wear and tear on components like capacitors is common in high-mileage vehicles. These causes highlight why regular maintenance and diagnostics are important for ECU health. Start with simple checks by inspecting for loose connections and corrosion that can disrupt ECU communication. Next, perform a full system scan using an OBD2 scanner to read diagnostic trouble codes and identify ECU-related issues. If you're comfortable with basic tools, test individual sensors like the camshaft position sensor using a multimeter to check electrical signals. For software-related issues, consider reprogramming the ECU with updated firmware to fix bugs or improve performance. If hardware failure is confirmed through testing, the ECU may need complete replacement with a new or remanufactured unit. Basic checks like inspecting connections and reading error codes can be done yourself using simple tools. However, complex ECU issues often require dealership-level software and specialized expertise that only professionals have access to. If you're unsure about diagnosing or fixing the problem, it's best to consult a professional mechanic to avoid further damage. Real-world examples demonstrate the serious impact of ECU failures. Volkswagen's Dieselgate scandal involved software manipulation in ECUs to cheat emissions tests, affecting millions of vehicles and causing health issues. Tesla Model S recalls highlighted ECU overheating issues, leading to sudden shutdowns and safety concerns in autopilot mode. Ford F-150 vehicles experienced misfires from faulty ECU capacitors, showing how hardware wear can cause performance problems. These cases illustrate how ECU issues, whether software or hardware related, can lead to widespread vehicle problems and safety risks. ECUs are evolving with advanced technologies. Integration with AI enables smarter diagnostics and real-time optimization of engine performance. Cybersecurity features protect against hacking attempts, which are becoming more common in connected vehicles. Predictive maintenance uses machine learning to analyze sensor data and predict potential failures before they occur, reducing downtime and repair costs. Secure software updates via blockchain technology ensure firmware remains tamper-proof and can be updated over the air safely. Future ECUs will be more sophisticated and upgradable, extending vehicle lifespan and improving efficiency. However, this also means potential for increased software-related recalls if issues arise in complex systems.